We're going to learn about direct variation this evening. So my goal for you by the end of this video is to be able to identify what is a direct variation, to be able to write an equation that is a direct variation, and to be able to graph a direct variation. Okay, so I've got a recipe for paella that calls for 1 cup of rice, and that'll make 5 servings. So in other words, I, as a chef, would need 1 cup of rice to make paella for 5 people. So I've got a chart here, or a table here, that shows me 1 cup of rice gives me 5 servings. Therefore, of course, 2 cups of rice would give me 10 servings. So if I were to try to write an equation that describes this relationship, then I would write that, and write that as a function. I would write that as y equals 5x. You'll see is that fit in our definition of direct variation. It's a special type of linear relationship that can be written in the form y equals kx. This is something you should be writing down. You need to know y equals kx. K is a non-zero constant. That's called the constant of variation. K is not a variable. That is a number that is fixed. Like the equation we just had where y equals 5 times x, describing our paella, that 5 is a fixed number. That k is not a variable. So, is this equation a direct variation? If so, identify the constant of variation. Well, this looks exactly like our equation y equals kx. So if it fits in that form, then indeed this is a direct variation. And here you'll notice that my k, or constant of variation, is 3. So k equals 3. Now I've got another one. Is this a direct variation? And if so, identify the constant of variation. Well, this isn't in the form I wanted. Remember, I need it to look like y equals kx. So first of all, I'm going to have to move this negative 4x. So I'm going to add 4x to both sides, and I will get 3y equals positive 4x. Again, I need to have just a y, so I'm going to divide by 3 on both sides, and I get y equals 4/3 x. Does that fit my form y equals kx? Absolutely it does. So this equation does represent a direct variation, and now I need to find my constant of variation, and that's my k right here. So my constant of variation equals 4/3. So now I've got another example. What do you think? I've got to move some things around, correct? I need to have my y over on this side, so I'm going to have to subtract 4x from both sides. So I have y equals negative 4x plus 8. So y equals negative 4x worked, but now I've got this plus 8. So indeed, I cannot write this in the form y equals kx. So this equation does not represent a direct variation. So now I've got a table of values, and I want to know if this represents a direct variation. So the first thing I'm going to look at is I'm going to try to write an equation. So notice my x becomes y by multiplying by 3, x becomes y by multiplying by 3. So I see that y equals 3 times x. Every time I had an x, I was able to multiply it by 3 to get my y. So does this fit the form y equals kx? Yes, it does. Therefore, this is a direct variation, and my constant of variation is 3. Okay, there's another way of checking to see if this is a direct variation. I can find the ratios, and remember we're looking for a ratio of y over x. So I've got, in the first instance, 6 over 2. Then I've got 12 over 4 and 18 over 6. This simplifies to 3, 3, and 3. Do I have a direct variation? Absolutely I do, because I've got a constant of variation of 3. So I could also write this in the form y equals kx, with my k being 3. Okay, so I've got another example. I want to know if this relationship is direct variation. And, whoops, I'm going to try using both methods. So first of all, I'm going to write an equation to get from x to y. Looks like I need to subtract 3 from my x. So my y equals x minus 3. So I've got this minus 3 here, therefore I do not have a direct variation. But I could also have looked at the ratio of y over x for each ordered pair, which would have been negative 2 over 1 and 0 over 3 and 4 over 7. So this ratio would have been negative 2, 0, and 4/7. So indeed, I do not have a constant of variation, therefore this is not a direct variation. So now I've got a situation where the value of y varies directly with x and y equals 3 when x equals 9. So I want to find y when x equals 21. So the first thing I'm going to do is find the value of k and then write the equation. Well, this tells me that y equals 3 when x equals 9. So let's see how that works. I know that y equals 3 and that equals, so going back, y equals kx, remember, is our equation for direct variation. So I'm just plugging in a value for y and I'm plugging in a value for x to help me determine what k is. So this is the same as y equals kx. To solve for k, I'm going to divide both sides by 9. Pretend that said 9 to begin with. And my k equals 1/3. So my k equals 1/3. I can then write my equation y equals 1/3 x. I'm going to solve to find a direct variation using a proportion. So here the value of y varies directly with x. Y equals 4.5 when x equals 0.5. So remember, it's a ratio of y over x. So when 4.5 varies directly with 0.5, and I know that this needs to be the same ratio, it needs to be proportional, some y, we're going to find out what, varies with 10. So I can actually cross multiply and solve for that y, and I find that y equals 90, and that will be my direct variation. So here's my real world example. I always love throwing those in at the end. I've got a group of people who are tubing down a river at an average speed of 2 miles per hour. I want to write a direct variation equation that gives the number of miles y that the people will float in x hours. So my equation would look like y equals 2x, because my hours for my x multiplied by 2 gives me my miles. So I could make a table of values to determine how I would graph this. So remember, this is a real world example. Can I have negative hours? No, I can't, but I can have 0 hours. And at 0 hours, I will have gone 0 miles. And at 1 hour, I'm going to have gone 2 miles. At 2 hours, I will have gone 4 miles. So let's go ahead and graph the information that I've got. I'm just going to draw a rough graph. I know that my X is my hours, that's my independent variable, and my Y is miles, my dependent variable. Here I am at 0, 0, and at 1 hour I've gone 2 miles. At 2 hours I've gone 4 miles. So I'm going to be able to graph that line, assume that it was straight, to represent that direct variation. Notice, what is my slope? Yes, my slope is 2. So we've actually gotten a little bit ahead of ourselves. All right, so make sure you finish your practice B and problem solving, and there's lots of IXL to be doing over the weekend. So come in and see me Monday morning if you have any questions. Otherwise, take lots of notes and have a great weekend.